Suppose we're asked to find the gravity on other planets using information that we can gain from secondary sources. So on Earth we can use these equations, force equals mass times gravity, and Newton's equation, force for gravity equals universal gravitational constant times mass of first object, mass of second object, divided by d, or distance between them, squared. For the purposes of this one, we're just going to use r. You'll see that used occasionally. I used quite a lot actually, sorry. At the surface, the force due to weight will be equivalent to the force due to gravity. So if we let one of these equal the other, now it's on a planet, so we're going to assume that this one is the planet and this one is the weight of the person, so they'll cancel. We end up with G equals gravitational constant times mass of the planet divided by r squared, and the radius of the planet is the r. So what we can use that then, if we have Earth, we get a known value of 9.8 or 9.80, depending on the values put in for the various parts of this equation. On other planets, we can use that value for Earth in the following way. So if this was Earth, we could take gravity on Earth divided by gravity of the planet, or we could take the planet divided by gravity of Earth. For the planet, we have G, mass of the planet, divided by radius of the planet squared, and then we divide, so we're letting one equation and we're dividing by the other equation. So here we've got mass of the Earth divided by the radius of the Earth squared, and we can then expand that, or instead of dividing here, we can multiply by the reciprocal. So we turn this one upside down, we get the following: planet Earth equals mass of the planet, radius of the planet squared, times radius of the Earth squared divided by mass of the Earth. And if we want the planet on its own, and this is all going to depend on what you're given. You might be given information for planet and Earth and need to find G. So in this case, we want to get rid of this part. So we're going to multiply this side by G, gravity on Earth. So we have to multiply this side by the gravity on Earth. So we end up with gravity of planet equals, now these G's will cancel up here, just change the colour so you can see. Mass of planet, and we can rearrange this in here, divided by mass of Earth times radius of Earth divided by radius of planet, and those were squared, so we need to make sure that's got a squared sign, times the gravity on Earth. And we might be given all of this information in the question, or we might be using it could be in a multiple choice or something like that. If we're not sure where to go, this is a way that you can get to this gravity of the planet. The other way is to rely on being given the weight of an object on that planet, and then using the weight equation. If you know the mass of that object, the mass is the same all around the solar system, all around. The mass doesn't change, it's just how much matter's there. But the gravity will change, and you'll be able to use this equation to find out the gravity. And sometimes this is done comparing it to Earth as well. So you're given a mass on Earth, the weight on the planet maybe, and then you need to find gravity on that planet. So a couple of different ways to find gravity on another planet.